Hello, teacher. Hello, students. Welcome to today's lesson on real numbers. In this unit, we have discussed many different sets and properties of numbers. Today, we will combine much of what we have already learned to study real numbers. I am ready to begin if you are, students. Let us start the lesson. Can you recall the different sets of numbers that we have discussed so far? The set of natural numbers includes all numbers greater than or equal to 1. The set of whole numbers includes 0 and all natural numbers. The set of integers includes negative, 0, and positive numbers. The set of rational numbers includes any number that can be expressed in the form A over B, where A and B are integers and B is not equal to 0. The set of irrational numbers includes any number that cannot be written as a simple fraction. Students, please write down each of the following numbers. Then, list the set or sets of numbers to which each belongs. You may work with a partner to complete the exercise.
Students, let's get ready. Let's get back to our lesson.
Hello, students. I am sure you had no difficulty with that exercise. Negative 12 belongs to the set of integers and rational numbers. 7 3/4 belongs to the set of rational numbers. 0.6 with 8,5 repeating belongs to the set of rational numbers. 3 plus the square root of 5 belongs to the set of irrational numbers. 0 belongs to the set of whole numbers, integers, and rational numbers. All of these numbers have one thing in common. They are all real numbers. Students, you have learned that every rational number is either a terminating or repeating decimal. Conversely, any terminating or repeating decimal is a rational number. Furthermore, you have learned that there are decimals that exist that neither terminate nor repeat. These decimals are irrational numbers. A decimal number can be rational or irrational. Every decimal number can be associated with a unique point on the number line. And every point on the number line can be associated with a unique decimal number. This is often expressed by saying that there exists a one-to-one correspondence between points on the number line and decimal numbers. Since both rational and irrational numbers make up the number line, we include both sets in the set of real numbers. The set of real numbers, denoted by R, is described as the union of the sets of rational and irrational numbers. Here, we include the irrational numbers like pi. Since all real numbers can be located on the number line can be used to compare and order all real numbers. For example, we can see that 1 over 2 is greater than -4, and pi is greater than 0. Students, see if you can put these numbers in ascending order. Ascending order means that you put the smallest number first and the biggest number last. It might help to convert each number to a decimal. Go ahead, students.
Students, let's get ready. let's get back to our lesson.
Hello again, students. Let us look at how each number converts to a decimal. 3 over 2 converts to 1.5. 0.49 is already in decimal form, and -1 can be written as -1.0. 0.48 is also in decimal form. The square root of 4 over 7 is the same as 2 over 7, which in decimal form is about 0.286. Finally, 1.1 is already in decimal form. Now it is much easier to see how to put the numbers in order. When you look back at the original form of the number, you will find that your numbers should be in this order. -1, square root of 4 over 7. 0.48. 0.49. 1.1. 3 over 2. How did you do? You may have noticed that it takes some time to convert the fractions into comparable decimals. If you do not have a calculator, it can take a lot of time. Fortunately, there are algebraic methods of comparing and ordering real numbers. Two important properties of ordering numbers are the trichotomy property and the transitive property of order. The trichotomy property says that for any two real numbers, A and B, one and only one of the following is true. A is less than B. A equals B. Or A is greater than B. According to the transitive property of order, for any three real numbers, A, B, and C, if A is less than B and B is less than C, then A is less than C. A third property is derived from the trichotomy and transitive properties. For any two non-negative real numbers, A and B, if A squared is less than B squared, then A is less than B. Take, for example, 3 over 6 and the square root of 3 over 2. If we square each fraction, we get 9 over 36 and 3 over 4. We convert 3 over 4 to 27 over 36 so that we can compare the numbers with the same denominator. Now we can see that 3 over 6 is less than the square root of 3 over 2. Students, I would like you to test this property further. Without using a calculator or converting the fractions to decimals, compare each pair of numbers. identify which number is greater than the other number. Go ahead, students.
Students, let's get ready. Time's up. Let's get back to our lesson.
Hello again, students. That was easy, was it not? 2 over 3 is greater than the square root of 3 over 6. When we square both numbers, we get 4 over 9 and 3 over 36. By multiplying 4 over 9 by 4 over 4, we can compare the two fractions. 16 over 36 is greater than 3 over 36. Therefore, 2 over 3 is greater than the square root of 3 over 6. Let us look at the second question. The square root of 47 over 10 is less than 0.75. Before we square the numbers, we can change 0.75 into its rational form. It becomes 75 over 100. Now, when we square both numbers, we get 47 over 100 and 5,625 over 10,000. We will multiply 47 over 100 by 100 over 100. And we see that this number is less than 5,625. Therefore, 0.75 is greater than the square root of 47 over 10. If you had any difficulty, I am sure that teacher can give you more exercises to practice after the lesson. Today, we have discussed real numbers. We have learned that real numbers include all rational and irrational numbers on the number line. We have seen how the number line can help us to compare and order real numbers. Until next time, thank you, teacher. Thank you, students.